Right, welcome everyone. We're going to start another stream of Zero-to-Quake-3 where we try and implement as much of the Quake-3 game as possible in a combination of Haskell and Vulkan. Let's see where we are. I believe on the last stream we looked at introducing reactive banana to begin to kind of formalize our game loop. And we mostly got that done. But the one thing that was, let's get the code up as well, the one thing that was lacking there was a fixed physics time step. So, yeah, the main kind of problem there is we were just, regardless of how fast this loop was running, so tick ends up basically calling itself, we were always stepping forwards 0.01 seconds, which doesn't really make sense. If this runs really, really fast, 0.01 seconds actually turns out to be much less than 0.01 seconds, and if we run slowly, then 0.01 seconds could end up being actually, in reality, like 0.5 seconds. So things go a bit weird. Let's just run and make sure everything's working, looking good. Feeling a bit. We might be having that exact problem. Feeling a bit jittery today. So maybe we'll put a FPS counter in as well and try and quantify that. Not sure why it's slowed down. But also I thought what could be fun first, before we go into that, is look at some user contributions. So Sam has been following along with the stream, pretty much every stream. SHF in the chat at the moment, and wanted to explore what we're doing with FRP, but using arrowized FRP. So I had a brief chance to look at this, but like rather than miss it, I thought it might be quite fun to just dive in and have a look at it. Oh, I see you've actually gone further and got concurrent physics and rendering, which is pretty cool. So yeah, the library that Sam's using is, how do you pronounce it? Dunai, I guess, which I'm not actually familiar with. So I guess it's a fairly new addition. Oops. So it looks like, I think it's grown out of Yampa. Yeah. Which I think I do remember seeing this actually, and I think it's quite similar to wires, which I have used in the past. Monadic stream functions. What are these? Monadic stream functions are, yeah, so they like take a step, produce a value, and then produce their next step, which is a fairly common way of doing this. Okay. So one thing that I saw, which did seem quite nice, was we kind of struggled a little bit on the last stream of getting data out of our FRP network. And what looked quite nice, I find this again? Oh, it might be in quake3.hs here. Was the kind of integration into the main game loop. So it's kind of cool that like there's in this render signal function, it doesn't explicitly loop. Yet we're feeding in this quake-3 state thing into the render function. So I like this this did look quite elegant. You just kind of feed something in, run it, and this monadic block just updates itself by the virtue of this Q3 state thing changing over time, because that's an input into the function. So simulation signal function then gets passed into the render signal function. Safely is lift that. What does that do? So yeah, re-implements Yamper with a simple core, but I'm skipping out on that and just using the core instead. And yeah, it's based on that monadic signal function data type that we saw. Right, okay, so this is just accept T. Oh, yeah. Oh, I see. So we're not actually using this safely, we're using lift MSF trans, which I guess is just lifting the accept T. Are you actually, I guess it's this fro or something that you're trying to capture here? It says reactivate. Okay, so yeah, it's the fact that we've chosen run accept T here, and reactivate works in this monad. So we're just basically lifting into accept T there. But is there any reason you're using it? Oh, so the accept T, I guess, is to allow you to hit Q to quit. Is that right? You want like early termination. Yeah, I guess it's that. Yeah, the exceptions are just to be able to quit the application. Anyway, so I like skim through it. It looks kind of cool. I'm going to stick with reactive banana anyway, just because we've already started. I don't think there's huge value in rewriting that anyway. But this does look quite nice. But I suppose it's not looking too bad. This kind of stuff, I don't know. This is where arrow syntax annoys me a little bit. First of all, I can never work out exactly how I want to format these like arrows and reverse arrows, which is, I don't know, cosmetic, but it's still important to me for some reason. So I don't like vertically aligning stuff like this. Just, I don't know. That's just a personal thing, and I don't like the tupling that you have to do with arrow notation. I find that a little annoying as well. But that said, you know, some of the stuff we're going to do in reactive banana it may well end up tupling, but we get applicative do notation, which might be nicer. Who knows? Anyway, yeah, so I didn't see that you've split stuff apart into this concurrent simulation rendering, so I kind of want to check out how you're doing that. So I guess it's this kind of idea that you've like got two kind of mailboxes that you push things into, just from seeing these T-bars being passed around. Is that concurrently? Okay, what is that coming from? Is that just async? Yeah. Okay, so if you're currently reactivating the two things, that's far too friendly for an id game as well. There's got to be something like "See You in Hell," surely. So the render one. Just reads this T-bar and then keeps doing renders, I guess. Yeah, it doesn't look too bad. I've been thinking about doing how we do it concurrently in the game that we have here, and the problem I haven't entirely figured out how to solve is you have these two threads operating concurrently, but I couldn't come up with a good way to guarantee that there was basically fair contention. So I didn't want to end up just like running the physically as fast as physically possible, and then the render loop never actually getting a chance to wake up and do its stuff. So for now, I'm going to keep it sequential. But there's no reason you shouldn't be able to just like do the same as what you've done, which is kind of two reactimates to pull two different things out of the system in different places. So anyway, that's looking cool. Looking forward to seeing where you go with this next. The way I did concurrency was to have read-write signal functions with STM, which is this reader SF that we saw up here, and using an STM variable for quake-free state, which is shared across threads, which isn't too bad. Let's start by measuring clock time. So the first thing I'm going to do anyway today is actually let's just get the plan up. Is to do this fixed physics time step, and I'm just going to take the almost final solution from Glenn's article called Fix Your Time Step, which is kind of a canonical article on getting a game loop in place, or a very simple one. I'm not going to go down to the final touch for now, and we'll just do this one. But basically the idea is you have your game loop here, you measure the time at the start of the frame and compare it against the time of the previous frame, and take the difference to get the frame time, which is the amount of time that was elapsed from the last frame. And then basically we're just going to basically step physics in a fixed time step as many times as possible that would fit into the amount of time that's elapsed. And there's this idea of an accumulator to carry over like an incomplete physics frame. So you're trying to run physics every 0.02 seconds and 0.01 second has elapsed, so you're halfway to the next physics frame. So that's what the accumulator is here for. It's written in a like C loop here, so we'll have to rewrite that in Haskell obviously. And then once you've done all of that physics integration, you just go ahead and render the result. So this should be quite easy to add in. For measuring clock time, we'll just use system.clock from the clock library, because that gives us access to the monotonic clock, which is kind of what you want to be using for high precision monotonic clock times. So the clock should never go backwards, which is exactly what a monotonic clock is. So let's bring this in. I quite like the API of this library as well. Nice and clean. So just system clock get time, the monotonic clock. Our frame time is T0 minus last frame. Something like that. There's going to be this kind of oddity that the first time I call this, the frame time will be 0, but that's fine. That just means it won't integrate the physics at all, so that shouldn't be a problem. We're going to have to, maybe we should use, this be nicer with, pass it in explicitly for now. Clearer than T0. Oops. Yep. You're also going to have to pass this accumulator, which is like how much is left over. What's the best way to do this? So one option is to scan a repeated subtraction of our physics time step. So let's actually introduce this constant as well. Time step x r. What does this num instance do? No idea what's going on there. Is it that? Yeah, okay, so it's nanoseconds, so no. Being super lazy here. What a great number. I'm just going to do a so yeah, one option is there a so scan L. No, I think I want to iterate actually. What we can do. Is there an iterate that doesn't use lists? Just kind of thinking a little into the future here, but cool. So we're going to repeatedly subtract physics time step from frame time accumulator. I could also just do this using math. We'll go with this one for now and see what it comes out like. Why do these just... I guess you don't know if they're going to be non-empty or not. It's annoying. So my idea basically was to take the frame time plus the accumulator, which is the total amount of time we've got in our budget, essentially, and then repeatedly subtract physics time step from that, which would give us a list, and then we could turn each element of that list into a call to reactivate. Maybe that's not the best way of doing it though. Because basically the problem here is, and then what I was going to do was kind of like, physics steps is basically take while greater than. But you actually want to span, and then this thing here, is your new accumulator. Which is kind of nice. But it doesn't work very well because span, or whatever it's called, gives you back lists, so this could be an empty list. But it's annoying because I know it can't be an empty list because iterate doesn't. Iterate is infinite, it never stops. So if there was a stream data type, we could do it. Code-free identity is an infinite stream, but there's not really anything useful in free that lets us work on that. Trying to find something that actually feels like functional programming here as well. I guess it's still functional programming if you did just use maths. Because, yeah, like obviously another option is we take this frame time plus accumulator, divide in physics step, take the floor of that, and then and that gives us the number of physics steps to produce. No, we're going with that either way. So what can we do? Time specs, not a huge amount. So we're going to need to what is nano? E minus 9. Is that right? Or is it 1 E minus 9? Do I want to? No, I want to divide or times by that. Divide. Yeah. Actually, I think we don't need floating point arithmetic here. Maybe we can use div mod. do need 2 seconds just because we're using seconds as our precision in reactive banana, which I quite like. Actually, I have a... Yeah. Okay, 1e minus 9 is 10 to the minus 9. Thanks for that. Always end up with some scientific notation up like that. 2 nanoseconds. Div mod is an integral, so it'll be a great idea to be passing integer around. I think worrying about the actual performance of our types is probably a little overkill for now, so we'll just stick with integer. Actually, yeah, okay, that's fine. See if we got that right. It kind of feels okay there. What if we slow this down? Oh, you can't do that, can you? Okay, well, let's do it this way. That's the second, which is obviously way overkill. It's like 10 frames a second. It should kind of feel like we're moving at the same rate. It seems correct to me. Oh, we didn't complete all the movement keys as well. That's something else to add at some point. But I think I'm happy with that. So that wasn't too bad. You know, it was pretty easy to wire in. Just getting a like this kind of recursive function is a little messy. I'm quite a big fan of the idea that this like what would you call it, like implicit recursion is a bit of a code smell, and we'd rather write this using some kind of combinator to work out when to stop being recursive, but I'll leave it for now. What else did I say I was going to do today then? Parsing the entities section of BSP files. Yeah, I think we can move on with that. So let's just make sure that this is all fairly smooth again. And the one thing I want to do here mainly is have a correct starting position. Let's work out like a proper spawn point, because right now I have to find the level, which is kind of annoying. So let's have a look at that. So there is an entry in our directory for entities. So let's grab that out. Entities, file bytes. Go to complain, we don't have that. So this is an ASCII format, I believe. Yeah, so this is what we have. I'm not sure if this has a real format behind it. Let's do our first dive into the Quake-3 source code and see if we can work out what it is. I have no idea where it would be in here. Ent data size. Parse this. Yeah, this looks good. Parse entity. Parse e-pair. So I think like they're gonna. This looks like a very loose schema, where an entity can kind of have any arbitrary key value pairs. A little bit annoying. So what are we doing? Nice. Just skipping some music. Okay. So I wonder, like, there's two ways we could do it. We could be true to the engine and just literally parse key value pairs, which is kind of annoying. Or we could write a more complicated parser that assumes a particular format. Yeah, that's a bit different, isn't it? I wonder if this is used anywhere. I mean, it is used somewhere, but I wonder how it's used. When do I usually stream? Hard to say. Usually, roughly this time, weekday evenings. A little less consistent on weekends. Yeah, it's roughly 7 to 8 UTC is kind of when I start streaming. Oops. What is SP info player deathmatch? This looks interesting as well. Kind of looks like a schema. Interesting. I wonder what these numbers are. So there's a bit there. Well, how is this thing used? E-cluster. Oh, we're in Q3 Radiant as well. So I guess, yeah, this is what gets used in the editor. I'm not sure I believe GitHub's search there. Oh, there's info player start. Still want to know what these numbers are. So we said, yeah, so it had origin. We didn't see that in that Q3 radiant thing either, actually. So I guess G find is, yeah, going to assign to this pointer anything it finds here and keep going through them. Okay, yeah, so it's these info player deathmatches that are the spawn points, and the origin is definitely the point of spawn. And then we've got angle on there as well. Just can't decide if we want to, where we want to do the parsing. I think if we parse into a list of maps of strings to string, then we could run another parser on that as a separate step. Let's try that. And this parser is going to be a pretty simple one to write, just to get this map. Maybe it should be BSP entities actually. I kind of like that more. I don't think it really has comments or anything. So this is going to be either a... Well, I actually haven't used the new Mega Parsec. I think I'm going to be stuck on an old version for now. Yeah, 6.3. I'm going to just use that rather than letting the new API. So I said it was going to be a map. We'll pass strict text into strict text. there are some monads that you want to use. Yeah, monad parsec. We're going to have many entity definitions followed by end of file, which I think is in here. That pass maybe say pass maybe also passes. Let's save this out. We can just read it in later. It'll make testing a little easier. We've got a between in here. Do. Oh, I've got rows, just space. Tokens, so data, text, text to data, text. is M ambiguous? What does space return? Yeah. That is a map. So between here we have many right, so this is lift A2, use a pair. Okay, that. I'm assuming this thing doesn't have like escapes and things like that, so let's okay. So many in there. Yeah, quote string only returns one of those. be able to do strict text refile, and map that into parse VSQ entities. Doesn't really do a much better job of showing me the error. Source line 931. What did we get wrong? I'm going to guess 931 is the end of the file, right? But what's that? Oh, it's null terminated. So we're reading one too many bytes. Can we rely on that, or should we find the null byte? Really say let's do this correctly and we'll find the null byte when we use this. Should it be a parse error here? Yeah, go on then. We should be using decode UTF-8 if it's ASCII. That gives us our strict text. I'm going to chain this slightly differently actually. Let's actually put the parser in there. Just kind of like that name a little bit more. Okay, so that's a lazy byte string. Yeah, that's kind of weird. We're doing questionable. We're doing. That's not that. It's kind of questionable that we're doing like ASCII parsing in a binary get monad. Yeah. Okay, so let's. Sweet. That was easy-ish. So now we could, yeah. Also, what did I get wrong there? Def math. There we go. Cool. So there are spawn points. I don't know what's. I guess spawn flags 1 is the default spawn point. Select initial spawn point. Yeah. That's it for 1. If it hasn't found a spot or that spot would telefrag somebody, then it selects, I guess, another spawn point. This intermission point could be cool to find as well. Maybe we'll look at that as well soon. So, yeah, it's what we want to do with these. I mean, obviously, yeah, the next step is maybe in our model. Do you do this with pattern synonyms, I wonder? Maybe. So I'm just going to like try and add a little bit of module structure and see if it informs our API design here. You know, I do like the idea of having a big like enumeration of options here. Like we have some types, let's use them. They didn't exist in C really when Quake 3 was written, so I'm going to do this as a sum type where every constructor has a corresponding record to go with it. Really wish we had anonymous records in Haskell because it'd be a lot easier to write, but we don't. I wonder if are there any entities that don't have an origin? Yeah. Okay. That's good. So I was just wondering if like maybe there were some common properties that all entities have, but it doesn't look like it. So info player deathmatch has angle, which looks to be an integer. Has a class name which we're not worried about. It has an origin. Why can't I see everything there? Oh, and it has spawn flags. Say v3 int for now. You take a map. Got to turn text into an int. Actually, maybe I'll put this in here. Nope. So we can get int. It's like read may in text, I think. Maybe. I don't trust you, Google. Pretty sure this got added. I should really be using my local Google. Keep forgetting about that. Yeah, so we got read maybe. Read. That's it. What? Keyboard's gone weird. This is in just text. Text.read. Where was I then? Entity, input player deathmatch. Yeah, so you'll now get it. From not that anymore. Oops. No, I did one, didn't I? Yeah. Yep, so the goal of today, well, the first thing we did actually was just fixed our physics time step. So we should get the same kind of logic independent of frame rate. And now we're just looking at the entities section of BSP files to try and get the initial spawn position, which is, yeah, as Sam said in the chat. We've got pretty far with it. We basically were able to parse the text out of the BSP file, and now we're looking at kind of interpreting which is basically a list of key value pairs. And because we've got sum types in Haskell, I want to interpret into concrete sum types, which I think is an okay thing to do. I don't think it's too much of an assumption to make. It might mean that we're not able to run like mods of Quake, but we could look at that later. So yeah, we're only looking at parsing this info player deathmatch thing for now. So maybe entity. You know what? It's already namespaced enough. So origin. That's not always there. Ah, I don't even have to write that because we get that for free. Yeah, for any applicative functor, which is pretty nice. Any alternative functor, I should say. So we need a v3 parser. So that's going to be look up that, unpack it, unwords? No, words. And then that's quite nice. It's come out pretty succinctly. If I put it right. Saving the file helps. Yes, that's pretty sweet. So because three-dimensional vectors are just functors, they're basically free tuples, we can just traverse read maybe over a vector of strings to get a vector of ints. And if we can't parse all components to an int, this whole parser will fail. So that's pretty cool. Like, that's come out really succinctly. So what are you complaining about? Yep. Yeah, so returning with record wildcards, I really like doing. This construction I use a lot. If I'm going to build up a record applicatively, rather than using applicative syntax, which then ties me to the order of fields, I prefer to write it this way, and then just use return with record wildcards at the bottom. Because then if I like reorganize these or add more things, it becomes quite clear when things are missing, which you don't get if you just use the applicative combinators. What have I spelled wrong? Yeah, so that's quake-3. Yep, now I need to... Oh my god, this is kind of, yeah, big boilerplate heavy. We could construct this with a generic traversal. I think I'm okay with it for now. So, how can I put this all together to test this? Let's load quake-3 BSP and quake-3 entity. Oh, I do not understand GHCI's module sometimes, but fine. I'll import the thing twice, because that's obviously what I meant to do. Can I just do M? And then I get prelude. Cool. Not quite what I meant, but I probably want that. And then add in... No, I don't need anything else. So, Q3, DM1... Take all the entities, over all the entities, map parse, map maybe, and quake-3.entity is not imported, cool. Oh, I need it for what? Ah. I'm not convinced that's right. I didn't think there was that many. What do I call it? Entity properties. Yeah. Where are these all coming from then? Where's this 181? Oh, I didn't check the class name, of course. I passed every single thing that has an angle and an origin into info player deathmatch, so that's not right. Get string, I guess. Text. Yeah, so somebody else caught me, so that'll pass anything that matches those fields, right? And yeah, it is missing the one with spawn flags equals just one. Did we mistype? It's spawn flags and we put spawn. So yeah. Well spotted. So we haven't got get text, and it's not enough to just get it. We need to guard that it's equal. There we go. So bring guard. Sweet, there we go. That looks right. 216, 132, 24, 56, spawn flags just 1. I think we got that. Correct. So, now it's just a question of how we want to wire this into our model. We give this could have initial entities. Initial spawn can be spawn flags. We will use our preview trick from before. So I want as info player deathmatch. So that's all our spawn points. I'm going to filter that. Oh, I'm going to sort those based on having possible spawn flags. Maybe we should use we'll just default to the origin if we can't find anything. Maybe, yeah. Right, so let's see. Is that the correct sort order? No. So we don't have entity in scope, so that's quake-3. No, I just no. Could not deduce error unless input led. Oh, I've got to derive generic. Oh, this one needs to be at my spell file. So on BSP entities. So what's going on here? Am I reading Quake-3 source from GitHub, then rewriting it in Haskell? Yeah, as Sam said, it's kind of in the middle. So we're not doing a one-to-one translation. Certainly not doing a one-to-one translation of the source code. For one, we're using Vulkan as a graphics library. But also, like now that we're starting to look at this game loop, we're using functional reactive programming and seeing how far we can go with that. How long does the estimate take to get done? Oh, I have no idea. But I'm not putting an end date on this. It's just something for me to do in my spare time, and I thought it could be fun to stream the whole thing. It's a little personal challenge, keeps me motivated. Honestly, at some point I'm probably going to burn out. It's, you know, the reality of things. I'm aware of that. But it's good fun so far. Quake-3 still use BSPs? Yeah, so definitely. I mean, I think BSP, if you mean the BSP concept or the BSP file format, which are kind of two different things. But Quake-3, well, maybe it was Quake-1 started the BSP file format, but Quake-3 BSP format is very similar to what Half-Life 2 uses, what Half-Life uses, what Counter-Strike uses. They all share a common file format, they just have different entries in the directory structure. And yeah, as Sam said, the BSP aspect, well, it's not used that much for collision detection. The BSP format now, they've got brushes which define kind of coarse geometry which act as collision. But actually, yeah, the way you do collision against these convex polyhedra is, well, it's not really BSP, I guess. It's just separating planes. I'm a game developer? No, not at all. I am a Haskell programmer, but I wouldn't call myself a game developer. I'm just someone who likes writing graphics code. We need containers. The BSP aspect, I'd say, of BSP files is actually more the way that it becomes triangulated from the level editor. So the level editor, you usually work with these brushes, and then you'll find splitting planes through that map, which will eventually have a single, if it's a single triangle, but a single face, which is all points on a common plane for every BSP plane. I think is correct. So what is going on with this generic stuff? I think the problem might be because we've only got one thing here. Yeah, so I might report that as a bug to generic lens. Kind of annoying that it's as doesn't work on things that only have one constructor. I think to do collision detection, the brushes are stored in the BSP tree, so you need to traverse that. And yeah, and certainly for the viz data, you would traverse the BSP tree that's stored in the file to work out what cluster you're in, and then you find what clusters are visible from that cluster. So yeah, there's definitely the BSP data structure is definitely used in this stuff still. So we need to pass in the initial entities here. So I think in our resources, we've got Q3DM1, which we should definitely rename. That's, can't bother doing that now though. Q3DM1 resources. Is this exported? No. So now is the time to rename this. Kind of weird that it's in the renderer as well. Okay, you know what I'm going to do? Rather than say rename, that seems a bit weird. So that's a BSP. I just realised we're going to have to swizzle the components, I think, of that origin. But I think we're going to find that out in a moment. Quake-3 entity pass, no, need to import that. Alright, let's see if this works. Yeah, I absolutely hate the dollar operator. I don't think it does any good for readability. I occasionally use the ampersand operator, which is basically the flip of that. Right, so this is not where we're meant to be, but we've definitely moved. So I think my guess is where is it? The XYZ here don't quite. Maybe it is. Or is it correct? No. I think the Z and the Y need to be flipped over. I think that's the order that they're stored as. I think that's correct, actually. Angle might be wrong, but I think that is where you start in Q3DM1. let's add the well. I need a reference. I don't have Quake-3 set up at the moment. Let's find a Let's Play. Unless any of you have got such a good memory you can remember exactly where you spawn in Q3DM1. I guess this is a good excuse to install Quake 3 as well and start playing this game again. Oh, that was quick. I thought that might happen. So what we're expecting is to be probably over here. Is everything flipped in the x-axis perhaps then? We haven't looked into that. That's one reason we might be over here. Don't entirely expect that to happen, but there's certainly meant to be some rotation here as well. Yeah, so we should be facing like that. Map is so symmetric. There's no distinguishing. If we got the meshes in, that might clarify it. So we might look at doing the meshes on the next stream because they're pretty easy to get in. They're just more triangles. Let's do the angle and then probably wrap it up there. You do have the meshes, you just need to change the test. Oh, they are literally exactly the same faces. Okay, so let's try that then. That's pretty cool. I wasn't sure if we had to traverse another list of mesh triangles, but apparently Sam says I just literally need to do one and three? Yeah. Okay. I was just doing some refactoring there so we can kind of pass the angle into camera angles. So we get this model on the left, which is one of the Quake-3 heroes, but I can't remember what her name is. How does that compare with this? So yeah, this is all mirrored, isn't it? you have the models the other way around. Interesting. I wonder what we got wrong here then. Quite peculiar. I did the coordinate transform thing. Yeah, so which, yeah, I remember you had your, like, that was like a Vulkan correction matrix, but we have one of those as well in this code. Maybe, yeah, I will have to look into that. I'm going to push that into the next stream though, just to get this bit finished. Here we are, info player deathmatch, angle, small point. Is that right? No, all the way around, isn't it? Yeah, 180 degrees would be pi. Well, that's cool. So we're parsing the angle and location correctly, but things seem to be rendered along the x-axis seems to be going in the wrong direction. Stick another correction in there, I think, but I don't know why that's happening. Okay, you definitely can't just stick a -1 in there. Oh, that's cool. I don't know what's happening. Oh, and the mouse is the wrong way around now as well. Oh, my winding order is the wrong way around. Yeah, okay. I don't know why I need that though. Yeah, so yeah, you just now I need to change counterclockwise. So yeah, it's my winding order of my triangles is wrong. Why do I have to do that though? Oh well. So that's reverse that, and Oh, it depends on if Z is positive or negative. Yeah, that's a fair point. Oh, so we've had this strange compilation error bugging us now for so many streams. Good news is on my machine, just forcing recompilation seems to fix it. Other people are not quite so lucky. What's going on here? A couple of warnings to fix up. But that should be spawn points working now, which is pretty cool. We'll try Q3DM2 after this, and we should find ourselves in a different location. Why Haskell? How much do I enjoy suffering? I've been suffering for 6 years. People are crazy enough to pay me to write this stuff. I love this language. So no suffering for me. I was writing Python a couple of days ago. Now that was suffering. Cool. So we're back. That looks correct. All feels good. Yeah, I think we've got a few more things now that we're rendering these models. So I don't think we had the horns up there. And the lions over here. That's taking shape. I'm always amazed actually just how much kind of detail you get just from the vertex shading. Just that basic light mapping goes quite a long way. Nice. I think that's a good point to stop the stream here. Yeah, so that's good progress today. We've got a kind of basic parser for entities, and we can kind of easily pick entities out. We're interpreting our first entity of the info player deathmatch one to correct our spawn location. And on top of that, we also just added some basic code into quake3.hs to basically integrate physics or step our physics handler forwards by a fixed time frame, and the amount of times we step that is going to be based on the amount of time that's elapsed between frames. So we've got a fixed time step. What is next? I don't know, like we've got a bunch of options. I don't know what people want to see next. One thing we could do is look at the viz data. So right now we're drawing every single triangle in the map. The correct thing to do is Quake3 maps are split into clusters. So if we fire this up again, for example, this region is one cluster, and you just draw the triangles in this cluster, but you wouldn't draw the triangles, for example, in this corridor because it's completely invisible. So we could look into doing that. We could look into loading light map data, which is in the BSP file again, which would require us to start looking at a little bit of texturing, but it wouldn't require us to look at the shaders entirely. So that feels like it might be quite good to look at soon, because we're going to have to look at shaders pretty soon, I think. What else do we need to do? We need to do the tessellation for the Bezier patches. That's why we're missing loads of, there's like gaps in the map. I think these are all patches. So we could look at doing that tessellation. And then beyond that, it's probably shaders is the next logical thing. And of course all the collision detection as well. Probably going to do that collision detection quite late. So, can't the GPU do culling? I mean, we can give the GPU that data. The data is basically in the BSP file format, so you get given essentially as an encoding of a function of cluster index to list of clusters that can be visible. So we could somehow try and upload that function to the GPU, which could be kind of cool. Do it in a compute shader. It doesn't really do it for free though. Like there's no like Vulkan flag I can turn on to cull invisible triangles. All it'll do is cull back-facing triangles, but they'll still go through the whole rasterization pipeline. They just get discarded. Yeah, so there's a bunch of options there. I'll have a think. If there's anything anybody particularly wants to see, let me know. I'm happy to kind of move things around in the stream to keep it interesting. If you want to follow more of this, just while we wrap up, all of the videos are getting uploaded into this YouTube playlist. So just, I don't know, if you just search zero-to-quake-3 or search for me or something, you should find them all. Obviously this is all being streamed on Twitch. If you want to follow some go live announcements and other miscellaneous stuff, I'm tweeting as @acid2 on Twitter, so you can follow there, and I generally tweet a little bit in advance when I stream. Next one will probably be Friday. Roughly same time on Friday I should be streaming again. But yeah, I'm going to wrap it up there, guys. Feel free to hang around in the chat a bit longer if you want. But yeah, see you on the next stream.